Hello everyone. Today I wanted to talk about how we use libraries in languages like C or C++. And in C++, we essentially find two kind of libraries. We have libraries that require header files and object files, and libraries that require header files only. And what I want to talk about today is the more typical kind of libraries, the ones that are very classic libraries that will come with a header file and object files. And the library I want to talk about today is libcurl. It's a library that lets you talk over all kind of networking protocol. The most typical one that you want to use it for is to talk over HTTP. And that is essentially the thing that you would do naturally with a web browser to check out some basic website on Firefox or Chrome or something like this. The reason why I like libcurl is because it's very versatile, it's very useful. I probably use it in a lot of projects, but also libcurl is a very classic C style library. Most likely, whatever library you're trying to use, it's probably going to look something like libcurl because it provides that very C-like interface. And whenever you're going to want to use a library like this, you probably will have to download or configure and compile the library yourself, or very often it comes loaded with your operating system, and in some cases you may need to install it. If you're in an Ubuntu or in an Ubuntu system, you do something like this. So you do apt install of the name of the package that stores it. libcurl is already installed on my machine, so I'm not gonna run it here. And on most systems that you're running to, libcurl tends to already be installed. One of the good things that I like about libcurl is that it has very neat documentation. It's actually very well documented. There is a programming tutorial that I suggest that you follow. And the library is going to have an easy interface, and I suggest you read the entire document to make sure that you're aware of everything that is going on with this library. But fundamentally, the library is pretty easy. We're going to need to initialize the library, tell the library which kind of URL we are trying to open. We're going to tell it what do we need to do with the data once we receive them, where to write this data back, and eventually just go ahead and perform the particular query that we're going to have. So let's give that a shot and see how that goes. So I'll write the code in a file called curltest.cpp, and I know that eventually I'm going to have to call this easy init function. You can see like the types are not quite given to me, so I can actually go ahead and check what the documentation tells me. It tells me that curl easy init return a pointer to a curl, which is some kind of a handle that you need to pass to all your curl function, and curl is defined in that curl.h. So let's go ahead and do that. We're gonna call this curl easy init. I'm gonna put it in a pointer called curl because we are polite, we'll read on 0. If you read the description of this curl easy init, what it will tell you is that whenever you call this, you're eventually going to have to call curl easy cleanup in order to clean up the data that comes with this curl. So we'll go ahead and do that call immediately as well. So this is probably the most basic curl application that you can write. It doesn't actually do anything. It doesn't actually talk to anyone. It just initializes curl and then is going to free it up. Whenever we're going to try to run this application, what we are going to see that it's not going to work. We won't be able to compile it. And the reason why we can't compile it is essentially that it doesn't know where to find that curl easy init. The reason why this is happening is that even though we have installed the curl library, it is going to be able to compile and actually find where that curl header file is, but it doesn't know where the library file is. We're going to need to tell it this is the name of the library that actually is going to store the functions that are baked inside of libcurl. And the best way to do this is fundamentally we're going to need to add some parameters to this call to G++. In order to do that, as usual, we're going to write a makefile. The makefile is going to read something like this here. It lets us define some parameters. Typically, the linker parameters are called LD flags. The linker itself typically is called LD here because we are writing C++ code. We need to override the standard linker and use G++ as our linker. And in order to use libcurl, we're going to have to pass -l curl. -l means you need to link your application against a particular library, and that library is called curl. And as usual, whenever we write applications, we will separate the binary that gets compiled out of an object file by coding the linker, telling it you have to write the file out to $@, which is the name of the target, it's curl test. It will take some input file, the name of these object files, and finally the names of the parameters for the different linker parameters. And we'll compile the .o file in the same way we usually do. Your .o file, you're going to compile it out of the CPP file. You're going to call cxx, which is going to be G++, pass it C++ flags. Here we don't have any. We need to generate an object file. That object file, we need to write it to $@, which is going to be curlTest.o. And it's going to take as input parameter this curlTest.cpp in order to compile it. And now that we've set up our make file, whenever we're going to call make, it is actually going to do the right thing. It is going to generate the .o file out of our CPP file, and then it's going to generate the binary out of the object file, and it's going to pass libcurl. And you can see that the error that we had before, undefined reference to curl easy init, has gone away. So very often, whenever you see this particular error out of your linker, it means that there is some functions that is not defined and that your linker can't find. So typically it means that you forgot to link against all your object files, or you forget to link against the library, or maybe forget to link against the correct library. And so now we have our first basic curl application. If we run it, it doesn't actually do anything because the CPP code that we wrote does not actually do anything. So we can go back to the tutorial that will tell us what to do. It tells us we can tell curl which URL we are going to want to access by setting the option of the actual URL that we want to pass to libcurl. So we are going to go ahead and do that. Maybe we won't actually access example.org. Maybe we can read that particular tutorial that libcurl has, and then we're going to have to make two calls to set the function that will tell libcurl what do we do once we have data, and where do we actually want to write those data. So what we're going to want to do is whenever we have data that come into our library, we are going to want to write it to a string. So we're going to go ahead and create an empty string. This string is empty, and what we're going to tell libcurl is whenever you're going to have to some data to write, I actually want you to write it inside of this my_up string that we have just created. The handle is curl that we're going to use. And there is something else that we are going to have to do, is to tell libcurl whenever you get data that you receive, what do you actually want to do with it? And this is something that you can define yourself. So here we're going to tell it whenever you have some data to write, you're going to call the functions called myWriteData. And you see that write data, it has to have this particular format. And the documentation of libcurl is going to tell you what these different parameters are. This is a very typical thing that you will see in a C library, where whenever the library has something to do, but it doesn't know what to do with it, it will call a function that you write. These are typically called callback functions. These are functions that you are going to write, and that is going to let the library know which function they are going to have to call and how they have to call it whenever something happens. In this particular case, it is the function that is going to be called whenever there is some data that needs to be written. It's going to call this write function. And it's a callback. That means that it's a function that you provide, but that will be called by the library itself. And the documentation will tell you exactly what these parameters are that your library is going to do. So I'm going to copy the parameters over. I'm going to call that function in the same way that I call it down there. I called it myWriteData, so that's what I'm going to call it. And then the library documentation tells you what to do. What it's going to tell you is that your function is going to get the data that is being written back in that pointer, it has a particular size and a particular number of values that get passed. And the documentation of the function will tell you what these things are. It will tell you that size is always 1, that PTR is where the data is, and that how much data there is in this parameter nmem. It also tells you things that are important, that the data passed to these functions are not null terminated, so they are not proper C they're not proper C strings, they are not terminated. And an important thing in this function is that the last parameter, user data, is the parameter that you passed yourself before. So it's going to be the pointer to my outstring object that I passed here. And so what that means is that I can get back a pointer to my string by casting it from that user data. I can take the pointer from the user data, I can cast it back in a string in order to get the actual string that I want to write my data back, which is this particular string. And then I can write the data back that came out of the buffer one at a time. I know exactly how many there are nmem of it. So I can iterate over all the the data that is in my buffer, and I can write that data back to my string. So fundamentally, what I would like to do is to write back pointer of I, and you can see that this my write data function, you can see that it returns a size t. You might be wondering, what am I supposed to return? The documentation actually tells you what you are supposed to return. It tells you your callback should return the number of bytes actually taken care of, and it tells you that if that number differs from whatever was passed, then that means that there is an error and that your application can't actually process it. So I will just return the number of bytes that I have actually written. So what that means is that now I have set up the call to curl so that whenever data come, it will be written correctly. The last thing that remains to be done is to actually call curl to actually ask it to do the thing it needs to do. And there is that curl ec perform function that you can call. It will take the curl handler, and whenever that function returns, then all the curl things would have been done, which means that implicitly curl will call this write function and pass it this write data, which means that all my data should have been pushed back to the string. We can see if that compiles. It does not, because I need to probably cast that to a pointer of some sort. Need to define strings. And now it is going to compile. Note that this does not actually print anything. So I'm going to print the actual contents of my string. And whenever I am going to execute this, this is going to print the result from the web page whenever I hit this particular link. And that actually worked. You can see it actually printed the content of this web page on my terminal. So in general, this is how you're going to use any kind of the C libraries inside of your C++ application. First, you're going to need to have to install it. Then whenever you're going to compile your application, you need to make sure that you pass the appropriate parameters in order to target and link the application to the particular library. Inside of the code, you have to include the proper header file that the library tell you how to use it, and then you will use it. Usually libraries are going to come with some kind of a tutorial. I suggest that you read the tutorial, but you don't just read the tutorial, also read the documentation of any function that you're going to call. Because these documentation are going to tell you exactly what the library does. and how it works and what it does whenever something does not happen correctly. Here, for instance, I'm calling curl easy perform. I'm actually not doing any kind of error checking. If you want to do error checking, which you should do in any real piece of application, read the actual description of the function, and the description of the function is going to tell you what that function returns whenever something wrong happens. And so in general, you do want to read the documentation of these functions in order to know exactly what they do, so that you can call the functions inside the library and be sure that you're actually using these libraries correctly.